Hi, everyone, and welcome to Elektor Lab Talk number 38. I'm Ryan Tristan Williams, joined today by my colleague, senior engineer Saad Imtiaz.
Hey,
Saad, how's it
Ryan.
going?
All good. How are you?
I'm great, thank you. Better than you, as usual, because you join us from 3.5 hours later time zone, so good evening to you. And since our editor-in-chief, Jens Nickel, is on vacation, we have a special guest. It's Sebastian from Baltic Lab, our old friend. He's an engineer specializing in RF and wireless technologies with extensive experience in designing and working with advanced wireless systems. How are you doing, Sebastian?
Pretty good. How about you?
I'm awesome, thank you. So, as the audience, thank you for joining us from all around the world as usual. I'm just checking the comments up there. We've got Germany, Dubai, Singapore, Hungary. So Singapore joins us from a late time zone as well. France, Germany, Delft, the Netherlands. So thank you all for joining us. We've got a lot to share with you about what's happening in wireless projects, Elektor Lab's contributions, and what our team is working on right now. Plus, I'll show off a brand new product from Raspberry Pi, which just launched today. But first, let's talk about our giveaway. In today's Lab Talk, we're giving away the WaveShare ESP32S3 Geek. It's a compact development board with Wi-Fi, Bluetooth LE, a built-in LCD, a USB-A port, and expansion header. So it's ideal for IoT projects, prototypes, and learning. And 2 lucky viewers will win it during the show. We'll give you the code word later, as always. Now, as they say, a word from our sponsor. Today's Elektor Lab Talk is brought to you by Elektor Academy Pro. If you remember, Academy Pro is our platform for engineers, R&D specialists, and makers who want to push their skills further with professional level resources. They have an expert level conference I'll tell you about. It's this one right here. Get ready for Zephyr, the open RTOS for future devices. This is a full day online conference from Elektor Academy Pro on the 5th of November, 2025. This expert-led event dives into rapidly growing Zephyr ecosystems, from real-time capability and secure firmware to driver development, Rust integration, and machine learning on microcontrollers. With 6 45-minute sessions, live Q&As, and unlimited access to recordings, it's the perfect way to level up your embedded and IoT skills. Early bird tickets are €199, so save €50 until the 8th of October, with special pricing for Elektor members. So once again, thank you for everyone. We've got Miami, Florida, just joined, Maine, USA, so people all around the world. I guess I'll dive right in here. We spoke last time about the wireless edition. That was this one, so we won't go into that one again. But since then, we have released a bonus edition for our members, so I'd advise that you check it out. It's I love the cover. This is a very clever cover that our graphics team put together. TRS connector is a wireless transmitter. Got a few nice extra projects that we couldn't fit into the original edition. So go to our website, check it out. We've got smartphone controlled Arduino projects, LoRa, infographics, and SMS. Remember SMS? That's still going, so check it out. Now, what we didn't talk about before, and since Sebastian is here, is in our Circuit Special Edition in August, we had some essential maker tips, and Sebastian contributed, and since he's the wireless and RF guy, I chose an antenna stock image. I like that. It's a multi-band antenna. Thanks for helping us with some tips, Sebastian. Did you enjoy contributing?
Yes, absolutely. And I mean and live every single tip I gave in there. Absolutely.
Awesome. So since we last spoke to you, what have you been up to?
Actually, a lot of things regarding electromagnetic compatibility. Just for fun, I created a little short with a small buck converter that's commonly used around the globe by hobbyists. And I just measured its noise performance, which was horrible and definitely not meeting any standards whatsoever. Now, the original chip isn't to blame. It's a China clone, so this was expected. And to my surprise, a lot of people were interested in it, yet at the same time, many people were clueless about electromagnetic compatibility, because it seems it's known that it exists, but very few people actually know what to do with it. They just know, okay, something doesn't work, might be an EMC issue, but how to actually measure it, There was lots of interest in it, so that's what I've been doing recently. And in October, there will be a lot more videos about electromagnetic compatibility. For instance, did you know that the orientation of an inductor does actually matter when it comes to the radiated fields?
I did not know that.
Most people don't. And I have no problem admitting that until a week ago, when I found an application note about that, I didn't know about it either.
And it's a buck converter, so you're talking power supply, right?
Yes, correct.
And yet you worked in your expertise with wireless and RF there. So do you often take into account interference from things like power supplies?
Nowadays, you have to. Most power supplies these days are switch mode power supplies, and all RF characteristics are, of course, present. Even if you have a switching frequency of, let's say, just 200 kilohertz, they are very sharp-edged signals, which, of course, create harmonics up into the gigahertz sometimes. So it's interesting that with the change to switch mode power supplies, power supply design has also become an RF topic.
And we'll talk more about power supply shortly, but as you said, it's a switch mode, so it's high frequency and it's therefore RF. What are the advantages? I mean, I'm going back 40 years, so back then they weren't switch mode. What are the advantages of switch mode? The disadvantages, you have to watch your RF, but advantages?
The biggest advantage is, of course, the efficiency. If you think of your old 7805 linear voltage regulator, everything that you didn't use did literally get burned as heat. Switch mode power supply, of course, regulates or varies the duty cycle. It just knows on and off, which gets filtered, and they reach efficiencies way over 90%. And this is the primary advantage. Ironically, like if you look in the automotive industry, where they have very fast drivers for the switch mode power supplies and for the motor drives, the biggest enemy of efficiency is actually electromagnetic compatibility. With silicon wide bandgap devices like gallium nitride and silicon carbide, we could switch a lot more efficient, like really a lot more efficient, but electromagnetic compatibility issues say no. So this is really the big challenge right now. We could be more efficient, but then we wouldn't be compliant, or we can be compliant and less efficient. That's EMC is a big issue in that area.
Interesting. I mean, I've worked obviously with 7805 devices, and one of the projects I remember from Elektor was a simple SVHS or composite video to RGB converter. So you're dealing with 0.7 volt peak-to-peak output and maybe 1 volt peak-to-peak input, and yet you've got this 5 volt regulator with a heatsink the size of a matchbox on the back of it for
Right.
dealing with those. It's okay, so that explains why you would use switch mode power supplies these days. And as I said, we'll talk more about power supplies because we always keep an eye on Elektor Labs. This is elektormagazine.com. How you get to the labs is you go to projects, about community projects. Actually, just click on electronics projects. You can always go to about if you want to contribute anything, and we've got quite a few interesting ones. And Saad has chosen, for example, this low noise power supply. Speaking of PSUs, Saad, what interests you about this one from Ton Gisberts?
Yeah, it's a really nice power supply, especially designed by our engineer Ton. It's actually made for more analog testing. So apart from using like any other switch mode power supply, this design avoids that digital or switching components. It uses 3 of the toroidal transformers and some filtering, and yeah, so at the end of the day you're getting 22 volts and 1 amp per channel. And I can talk about this all day, but it's a really long project, so I encourage everyone to check it out. A very detailed, nice project, and the files are also available, so you can make your own as well.
Good. It is a long project. Tom put a lot of work into it. I'm just glad to see he didn't use any 7805s there. So yeah, audience, check that out. And for me, I'm normally the digital guy. I like microcontrollers and stuff, but since we're talking about wireless today, here's a combination. You can get your RTTY weather reports on a mini radio with a display. So It's radio teletype, and I looked into it, and it dates back to like the 1920s with experimental systems appearing not long after World War I. So it really took off in the 30s and 40s, and by the 50s they were using it for news agencies, ships, and amateur radio operators. So basically 100 years old, and I love this project because it mixes old school radio with modern tech in such a cool way. Look at the display there. Something satisfying about pulling real weather data out of the air of a shortwave. I also like pulling time, but nowadays we've got GPS for that. But now with an ESP32 doing decoding and showing it on a little screen, it's wireless communication, and it captures that retro spirit, which I like. Next one was also highlighted by Saad as an interesting one, wireless scales.
Yeah, this is one of my favorites because I personally need it. Normally, when you're traveling, you have to, if you have a weighing machine, you carry your bag and get on the weighing scale and subtract your weight from it in order to find out what's your the weight of the bag. So this project uses an ESP32 with some load sensors. And yeah, so there are two scales, both communicate with each other, or three of them communicate with each other via ESP now. And the receiver node shows the individual weight and the total weights of both sensors. So it's a clever solution. The author made it primarily for his bike, to weigh his bike. And also it can be used for other applications as well.
Why does he want to weigh his bike?
I don't know. Maybe
Yes,
he's
getting on.
doing some bike mods.
Perhaps, or maybe he takes his bike on an aeroplane and checks it in. Nice project, though. When it said wireless scales, I almost thought he meant contactless scales. I've heard about those for trucks, where they somehow manage to weigh trucks without touching them. You guys know anything about that? No idea. Okay, so as promised, the new product I wanted to talk about is from Raspberry Pi. It's not 100% wireless related, of course, but it does have wireless in it. It is well, I'll first give you some background. This was the Raspberry Pi keyboard and hub, but this is just a keyboard with some USB outputs at the back. I have to cover my face to get focus. And the matching Raspberry Pi wired mouse. I'm still looking at you, Raspberry Pi. I would like this to be wireless, please. Got enough cables on my desktop. Then along in December 2024 came the Raspberry Pi 500, after the Raspberry Pi 400, of course. Now, Raspberry Pi has come a long way since the original. I mean, I looked at this today. I've had this since, well, at least the copyright date is 2011. Good old composite video output there. And then the first keyboard with the built-in computer was the Raspberry Pi 400. Now, there wasn't a Raspberry Pi 300 or a 200 or a 100, so I think one of the reasons that they started with the 400 was because it had the functionality of the Raspberry Pi 4, pretty much the same specs. But after having spoken to Evan Upton, he also alluded to his growing up in the 80s with computers such as the, for this one, I'm going to have to move backwards, the Amiga 500, and it weighs a ton. So yeah, he did say that they were working up to the 500, and then we got the 500 right here, which is a great machine. And this one of mine here has a micro SD card in it running the operating system. And today, just launched, is the Raspberry Pi 500 Plus. Now this one, if I could turn off the background noise reduction so you can hear everything, okay, is a click keyboard. Don't know if you can hear that. Plus, it has RGB LEDs in the keyboard, so plug it in here. And that's the power on sequence. And I had it plugged into a Raspberry Pi monitor earlier today, so I'll just bring that web page up. One of the few times I would actually use an animated GIF, but you got it for the RGB LEDs. So there you go. That's the first time boot on the Raspberry Pi 500 Plus while connected to Raspberry Pi monitor. You don't see the mouse because that would mean an extra cable. I did manage to find a wireless mouse that kind of looks like the Raspberry Pi one. Read more about it at elektormagazine.com. But I can give you some basic specs. Raspberry Pi 500, December 2024, 500 Plus. Now, today, September 2025. And basically the 500 has 8 gigs of RAM. This has 16 gigs. The storage on the 500, as I said, micro SD. And when I opened the box, there's a micro SD slot in the 500 Plus, but there was no SD card. And I was like, you guys cheaping out on me? But no, actually inside there's a 256 gigabyte NVMe SSD. So you can use micro SD, but it's got M.2 expansion. And the keyboard, as I said, is it's got Gator-on switches with RGB LEDs. If you don't like that clicking, it could annoy people. They actually have an accessory kit that you can put rubber bumpers under each key to stop the clicking. So you've got double RAM, built-in fast storage, a mechanical RGB keyboard, and a higher price. So it's $110 higher in price. It's $200, as Eben said to me, definitely their most expensive product. But let's compare. This was $699 back in the 80s, and that I looked at the inflation, it works out to about $1,800. And this one had a 7 megahertz CPU, and well, the Pi 500 Plus is in the gigahertz. So that is our new product launch. But yeah, have a look at our website and check it out. Also, if you have any questions, please drop them in the chat. And Saad, you've been working on some stuff. Would you like to share your screen with us? Tell us what's been going on in your world.
Absolutely. I would say this month I was very busy with on my computer instead of in my lab. So I was working on the LoRaWAN Sense node. I just shared my screen. Yeah.
Okay.
So yeah. So last time we just discussed about just a block diagram. With this time now it's in proper PCB. So I mentioned some specs on the back. So yeah, it has a GPS, a LoRa, ESP32, solar charging, and a timer. So it has everything on one PCB. In the last LoRaWAN project, it was more modular. I designed a specific board for a Shao board, and then I was plugging in all the modules which I need. But for this one, yeah, the main ones are on board. So you got a ESP32, the LoRa, the GPS. You also have a MQTT charger, which can charge the battery via the USB as well as solar. And then specifically, a lot of time was spent on how to minimize the power. So there were a lot of ways of doing it, but eventually I just came with these timer ICs, which take about current in the nano ranges, even very below 0.1. Yeah, so you can set the time from, I believe, 1 minute to in the hour ranges just by changing a resistor. So that's pretty cool. And then if you want to bypass, then I introduced these jumpers on top of it. Then there's a little bit of I/O, some SWD for debugging, the ESP32 and the rack. So it's pretty nice. I'm really excited about this one. Right now it's in production. So when it comes back, I'm going to be really testing it and making the firmware for this one.
Well, that's great. And it's nice to have an Elektor Labs project out again. The last show I did was about FPGA, and somebody asked if we could put out an FPGA project. So it's always nice to have these projects out that are custom made by Elektor and collaborators such as Sebastian. Sebastian, if we were to make a project in collaboration with you, what would it be?
That's a really interesting question. What would it be? At the moment, I'd probably say a transient generator for electromagnetic compatibility testing. That's a good idea, because there is a LISN project, a line impedance stabilization network, that you need for measuring that Elektor already has. And the interesting part would be transient testing. This is where you inject or basically torture your electronics with transients, which happen in the automotive industry for testing. That would probably be it, yes.
Awesome. And Saad, you were also working on another project. Ready to tell us about that, or is it top secret?
Absolutely, yes. It's one of the favorites from our community, the ESP32 energy meter. So as I mentioned in my articles, that I will work on something regarding AI, and I got a lot of emails, and then it just went to the backlog that, okay, I will make something regarding AI, as I wanted to detect some appliances around my house using AI. But yes, as of course I mentioned before, that it requires a lot of sample data and labeling and everything. But just to take first step towards it, I collected this data from one of the phases. So this is primarily recording AC data. As you can see right now, it's on. It's taking 4.76. Yeah. So I downloaded data for about for entire month, and then I used Edge Impulse for that. I used a little bit of a chat GPT to label stuff, as I know that on this phase, when the current is above 1 amp, it's probably the air conditioning is on, and above that is air conditioning is on. And then also there's a fan in the middle which takes about 0.5 amps. So writing some Python scripts with ChatGPT in order to label my data, and eventually came up with a lot of data, about 112 hours, which is enough. But of course, it's just about an air conditioner. It's not too many devices, but for starting, it's pretty good. So at the end, I would say it's working fine. But I'm not really happy with the other stuff, because it's only able to detect 90% accuracy just one air conditioner. But if I want to detect a fan or some values on the lower end, like below the amp, then it's a little bit harder to detect, just like a fan. And even if it's above, let's say 6 amps, 2 air conditioners are working, then it cannot detect that as well. So it's only able to detect an AC right now. And I would say I would blame the data that I collected. And I need more samples, of course, and then more test data, as well as more training data for other appliances. So it works like this. If you have more data for an air conditioner, then we'll be more trained towards that. But if you have a more balanced data, so I would say for each situation, you have a lot of similar amount of samples, I would say that would be able to train much better. But right now I'm testing around it. I tried multiple ways to make this better. But the ones which work the most is that first I started with the window size. You can decrease it according to amount of your samples. But first of all, I increased the sample window size to about 30 seconds, then 20, and I think I'm getting the best accuracy around 10 seconds for both of them. But at the more samples, I would say the more window size, I was able to detect, let's say, fan and as well as AC2, and when everything is off. But of course, the accuracy was way low. So I would still blame again to my sample data, and still keeping an eye on my energy metering and trying to get more good data so that I can feed the data again and train this model again to see whether it's worth the shot or not.
Interesting. I mean, Edge Impulse has been a very popular topic these days. So I'm trying to work on a project as well, where it's voice recognition, but instead of Alexa or Google and whispering because I don't want to trigger people's devices, you can say, "Hey, Elektor," and get a response from that. But that's the only Edge Impulse project I've really worked on. Have you done much of this, Saad, besides this project?
No, this is actually one of my first ones with Edge Impulse. Much while back, I tried to work a little bit with vibration. So trying to find out whether what's the status of the machine, specifically lathe machine. And that was pretty easy to do because you have a bunch of data available, and we had a lot of data for it as well. And I was not the only one on the team working for this, so it was easier. But this one, I have to label everything, and it's a little bit harder to do. And first of all, yeah, you also have a lot of examples built in Edge Impulse for that application as well. This is yeah, we don't have a lot of data, so of course with the machine learning you need to have a lot of labels, samples, and very refined data in order to train something that works as you want it to.
Do you find that when you get to a certain amount of machine learning data at the top, it starts to give you less and less advantage to giving it more data?
I would say even if you have like I have 112 hours, I believe. But I even seen good models which have only 10 hours of data, or even 6 hours of data. But it needs to be a really good data and very balanced data for all the states. As in, if something is idle running, or running in slow mode, fast mode, or there's some sort of anomaly, you need to have a sample for each of the stuff or each of the state in order to train the AI, and so that it can learn from that. But yeah, if you have more data for, I would say, if I have the most data for AC1, that air conditioner is on, then yes, of course, it will be identifying that their air conditioner is on very easily. But the rest of the data is there's, for the other labels, the data is quite less. So of course, it is able to label it by itself really good, but yes, you have to have balanced data so that the classifier feature can be applied or trained as it should.
Okay, yeah, because the reason I'm asking that is I've trained voice models on cloning my voice, and the people who were offering the service, I think it was 11 labs, they said you could do 2 minutes or you could do 2 hours, but really there's a sweet spot in the middle. You don't need to go overboard.
Mm.
And Sebastian, have you made... so carry on, Saad.
Yeah, I didn't find a source which says that, but of course, yeah, you are right for sure. But I was not able to find a source for this type of data, that for this type of data, how much is a good limit. And like I said, it needs to be balanced data, as well as here. If you see here, so in the test and train split, it's quite unbalanced anyway. I can simply click perform train and test split, but then I don't get what I want. So that's the problem. It needs to be a quite balanced, really good data. And I said so much data in this entire conversation, but it actually really matters a lot.
Awesome. Well done on what you've achieved so far. Look forward to seeing that in print later in the year. Let's see. About your LoRa project, Ben Martin says it looks great. And then looking back at the computers we were discussing earlier, somehow in the past, the cost of computers were always about $2,000. Okay, Sebastian, we've got a question for you here.
Oh boy.
Well, it steers us back to wireless, which is where we belong in this episode. Dealing with interference in 2.4 gigahertz devices like antenna placement basics, or how to measure signal strengths without lab-grade equipment. You have experience in that.
Yes, the interesting question would be what old news rates as lab-grade equipment. You would, of course, need some sort of device that is capable of measuring RF amplitude. So ideally, the Nano SA is the cheapest spectrum analyzer you can get. But to get this back to actual signal strength, if you just hook up some antenna to a spectrum analyzer, you get some amplitude, but you don't really know what the real field strength is. For that, you need a real calibrated antenna. Now, there's actually one sitting behind me, this beautiful thing right here, but I think this would count as lab-grade equipment again. This is a biconical measurement antenna. The special thing about this is there are antenna factors which can be related directly to field strength. If I hook this up to a spectrum analyzer and I measure some value, I can directly relate to the field strength at some distance. Now, I would argue that this qualifies as lab-grade equipment. So what can you do? You can always determine the antenna factor of antennas if you have two of them. So even if you order a small antenna on Amazon and just have a simple diode detector, which I guess would be, it's still lab grade in some way, but it would be hobbyist lab grade. If you have two antennas and you measure the insertion loss, and you'd again need a vector network analyzer of some sort for that, or at least a spectrum analyzer with tracking, you can derive the antenna factor and from that directly measure field strength. So it's actually fairly accurate. The limit of lab-grade equipment bothers me a bit because everything is in a way lab-grade. I assume you mean hobbyist grade or home lab grade. At bare minimum, you would need some antenna that it depends. Do you want absolute field strength or do you want relative field strength? If you just go on hunting, a electric field strength and measurement could be done with a near field probe. You can build one on your own. Although do I have one sitting around here somewhere? Yes. It's always convenient when there are questions to stuff that I have sitting right behind me. Let's put it in there. Okay, ZVE10 won't focus unless I hide my face. No, it won't even focus. There we go. This is a simple E-field probe that you can use for relative probing around. You can build them on your own. So if you're just looking for relative indications, as in locating interference that you know is there, you can use that. If you really want absolute values, you're going to need a special measurement antenna or derive antenna factors on your own. And if you can clarify what you mean by lab grade, I guess that's what you meant, just hobbyist level, then that would be my answer.
Well, there's a wide range of different equipment between hobbyist and lab grade. I remember bit banging parallel ports because I didn't have a logic analyzer, and the big boys in the labs can afford all that stuff. Could you show me that gadget with the antennas on it, the E-field detector?
Do you mean this or?
Yeah.
That's a biconical antenna, yes.
Okay, looks like an egg beater, but what sort of frequencies does it pick up?
This one goes from 300 megahertz to 3 gigahertz. This is quite a large range. And like I said, the special thing about this antenna is that it is the antenna factor and the gain is actually calibrated by the manufacturer. The manufacturer is TechBox, by the way, and the antenna is called TBMA1B if somebody wants to look it up. Actually, it says on there 30 megahertz to 3 gigahertz. My bad, I lied. So even more, 30 megahertz to 3 gigahertz. And the antenna factors and gain are given over the entire frequency range at different distances. The distances are 1 meter, 3 meter, and 10 meter, which is kind of what the CISPR EMC standards call for. So if I put an object like, let's say, 3 meters away, I can tell precisely with a spectrum analyzer how strong the electric field strength is. And since at the far field, the magnetic field and the electric field are in a relationship to each other only determined by the free wave impedance, I can also tell the magnetic field, of course. These things are awesome. They exist for different frequency ranges. They aren't even that expensive. I don't know the price of that one off my head, but having these antenna factors and very granularly specified gains is really important. You can also calibrate other antennas against it. If you have some cheap 2.4 gigahertz antenna, like for your Wi-Fi router or ESP project, and you want to verify what the gain is, if you have a known reference, you can do that, of course.
Cool. And I've got an upcoming question. I want to bring up this picture again. This is a stock image I chose. We didn't have antennas like this really in South Africa. You can see there's a UHF in the front there, but that ends at about there. Then you've got various grades and it gets wider and wider. But I think in America, they use those wider antennas for much lower frequencies for television. I can't remember the frequencies exactly. It could have been below FM, I'm not sure. Your meter it picks up from 30 megahertz to 3 gigahertz, so that's below FM radio. And I'm also curious now, because you're in Germany, Saad's in Pakistan, I'm in South Africa. Interesting question. What sort of antennas are still in use domestically? RF, FM, TV? I can tell you that in South Africa, they have phased out UHF television, analog, but they haven't switched off analog completely. They're still running VHF in the 175 to 255 megahertz band, which is not used in the UK. We use the same PAL-I system as the UK did, but they never used the VHF band. All their TVs were UHF only. But most people here don't use domestic terrestrial television anyway, even though we have digital services. Everyone's moved to satellite or internet. There's just so much more content there. People would rather buy a data bundle for their tablet and watch something there than plug in an antenna. And then, of course, we still have FM. I don't know anyone that uses AM anymore here. And then, of course, I guess we have antennas built into all our devices, Wi-Fi, Bluetooth. But how could you speak to that? First, you, Saad, in Pakistan, what sort of antennas are you seeing flying in the air?
Yeah, we normally don't see them. Normally, we just see them on cars. So AM and FM is very common. For TV, yes, we do have cable. I don't remember in my lifetime that I used antenna. In some remote areas, yes, maybe they use antennas, but yeah, the cable coverage and the internet service is quite wide, and people do get a lot of data bundles to check on the news. So yeah, I would say these two are quite common, AM, FM.
Yeah, I'm still nostalgic, and as I said, they haven't completely turned off analog TV in South Africa. They're about 15 years late with the project, and they're going to do it any day now for the last 10 years. So I'm hanging on to antenna and some CRT monitors because I want to capture the moment they switch it off, just for historical purposes. But what are you seeing? Sebastian, I've been in Germany and I saw some aluminium antennas on the roofs, and I asked my German friend and he said, no, they've switched that all off. But then I looked into it, and I think there is a digital terrestrial television service, so people can still use their antennas if they want to.
That is absolutely correct. Yes, we've removed all analog television signals. There are none around, but the exact same frequencies are now occupied by the DVB-T standard, which is digital television. If you own a house, most of the time you're just gonna put a satellite dish on the roof. But you're absolutely right. The same antennas that we used for analog TV can still be used for the digital TV. However, most people don't. They just use indoor antennas of some kind. It's a big difference. Same with FM. Of course, FM is still quite popular here, although the switching it off is being discussed for the past 5 years. If you have a huge complex with several apartments in it, there's still going to be huge antennas. You know what? Give me just 1 second. If I can get it in the frame, I'll show you a broadcast FM antenna. We're not going to be able to get this in the frame even remotely.
Yeah.
I'll put it on the ground next to me so just so you can see the height. But this is a Yagi antenna. Back here
is that a quarter wave?
Yes, although it's looped, there's a trick. I can't get this even remotely in the frame. Here you can see there's a loop around to make it physically smaller. But this giant thing, maybe we can get more in the frame like this, you'll oftentimes find on roofs of apartment complexes for FM TV.
You mean FM radio?
FM radio, my bad. Yes, of course.
Yes, I had lots of antennas back in the 90s. One I wanted but never quite got around to getting was an FM, because we could get good enough reception indoors with a piece of wire. But
Yes, same here.
the recommendations were always to use a high quality outdoor antenna to avoid multipath distortion. So I never got one, but wanted one. I've got some more questions on wireless and analog, but hold on. Let's take Sebastian out the frame and then go back to our giveaway because it's time to do the code word. Find the correct tab. Put that up. There we go. So as I said, we're giving away one of two Waveshare ESP32 S3 Geek boards. This tickled my fancy when I first saw this. It's got so much in it. Micro SD, an LCD display, and it's got wireless and Bluetooth LED and 16 meg flash and all of that. So very cool device, and we're giving away two of them. So today's code word is geek, since it is ESP32 S3 Geek development board. So please enter the competition. There's the URL on screen, Elektor-Lab Talk-giveaway on our website, elektormagazine.com. So whoever wins, have fun. Then Sebastian's already answering questions I was about to answer. From W. Cromley, the question was, could you please give a link for the details of the biconical antenna? And thanks, Sebastian, for helping out with that link. techbox.com/product/TBMA1B-biconical-antenna. See, we're not the only ones with long URLs. And Ben Martin's also helped with that information. Gordon says, interesting antenna topic. Thanks. Yes, I enjoyed that too. I still go back a while on that, even though I don't use any antennas. I took my satellite dish down about 10 years ago because the internet gives me everything that I want right now. Sad, but true.
Yeah. Same here. The only antennas I have on the roof are for my software-defined receiver. And yeah, no, TV and radio, I listen over the internet. That's actually not completely true. Sometimes you said you don't know anyone listening to AM anymore. You do know one person. That would be me. Sometimes in Europe, mostly AM is dead, and I think we talked about that in the live stream before. But there's one station, Radio Caroline in Great Britain, and it's so fascinating that if conditions are just right, of course it has to be dark, you can listen to it even on a small pocket AM radio here in Germany, inside my office, inside a concrete building. And sometimes I do that, but other than that, even for that, I don't have any antennas outside.
Interesting. And Radio Caroline, was that the pirate radio station?
Yes, they originated as a pirate station. They had the idea, well, we aren't in British territorial waters if we just go a certain distance on a ship outside of the bounds of Great Britain. So they blasted their radio program from there into Great Britain. And of course, the regulatory body, the Ofcom, didn't particularly like that. But at some point in time, they agreed, and now they are licensed and everything's legal. Yes, it's very interesting to listen to that, especially you get a feeling for all the effects that are at place. I just mentioned it has to be dark between here and Great Britain. Obviously, there's a zone when it's gray between here and there. Let's call it gray because amateur radio operators also call it gray line DX. And at that point in time, from daylight to night, you hear the transition. You can literally hear the path closing. And that's very interesting to observe these effects, because if you have this audio feedback, you of course develop a better feeling for these effects as if you're just looking at field strength.
Yeah. And when I talk about AM, I think I'm talking about medium wave, which is your kind of domestic AM broadcast. I'm not talking shortwave, yes, where you can pick up VOA from around the world. Radio Caroline, what frequencies ballpark are they on?
They are exactly on 648 kilohertz, 648. Okay.
So that is your domestic AM. We had a radio station here called 702 since the late 70s or the 80s. It was a talk radio station, and it was independent. And our government controlled all the FM airways and licenses for TV. It was basically all government. And they fought for years to get a license for FM. But they were on 702 kilohertz Eventually they got a license, but they didn't change their names. So now you can find 702 on the FM dial, even though their frequency is not 702 kilohertz. Interesting history of these.
In the United States, this is still quite popular. There's a lot of low power AM and even FM stations. This is typically a church thing, but also a school thing. Apparently, the FCC in the United States is a lot freer on giving out licenses. I know in Germany it's next to impossible. Don't even try. I mean, you can, but then you need to have a really big bank account. But in the United States, in almost every neighborhood, especially in the rural area, you're going to find local AM stations. And I think we have some Americans in the guests, so in the chat, so somebody can probably say something about that.
Yeah, America has a very interesting, different free model, despite what's happening these days with Trump and the FCC threatening the broadcasters. But in South Africa, it was somewhat like East Germany in the 80s, in which you had a national broadcaster and every city received exactly all the same channels where they could get reception of it. Whereas in America, you've got big networks that do not broadcast to people's homes. They just send out their programming to local affiliates, and the local affiliates have the licenses. So that creates a wide variety of very interesting content, and people with antenna rotators in America, so that they could pick up from one city, and when they want to watch something else, they used to press the button and the motor would turn to another city. So that was very interesting. America has a very interesting free market in that sense.
Indeed, yes.
Renee Bosch says, I still use the electronic indoor Koenig ANT 118KN FM antenna. I don't know it. Maybe you do, Sebastian?
No, I do not, but Google knows. So, oh, that one. Yes, I've seen it, but never used it. But this is a typical indoor antenna, Zimmerantenna, as we call it in German, which are so popular. Like I said, those huge antennas on the rooftop, you usually just see here if somebody owns the house or if it's a big apartment complex. The typical student or person living alone is just going to put up one of these antennas inside their room. And usually in Germany, in most locations, this is sufficient. We have enough coverage, especially since most TV and radio stations, they are multicasting on the same frequency from different locations. And yeah, you're always going to pick up a signal somewhere.
Yeah, I did mention before, but I'll mention again. Hope not to bore you, but I did try my hand at shortwave back in the 90s just so I could like learn German or something, but I found it very difficult to get a signal. I just didn't know much about shortwave antennas, and we didn't have Google to help those days. I just used to plug in some high power electrical wire, and the longer the better, but the signal never got any better. So I could have learned so much back then. I love these Zimmer antennas. You have stricter regulations there as well. I know the UK and even some places in the US, when they had C-band antennas, what guys used to do is they couldn't get planning to put up a C-band antenna. So they would invent something that covers the antenna that it looks like a garden umbrella. So it's not an antenna, it's a multifunctional outdoor umbrella for my garden table. A lot less regulated here. You will find a lot of apartment complexes with tons and tons of antennas. It's an eyesore, but hey, that's the price you pay for freedom.
That's right, yes.
What else do we have? Oh, Hans Schneider, the LILYGO T-Deck ESP. We wanted to give that away today, but it ran out of stock, so we're hoping to get more and perhaps give it away in a future show. We checked our stocks and it was so popular that we're all sold out, so we don't want to disappoint you. Ben Martin says Radio Caroline in Great Britain and Veronica in the Netherlands. If only I had one of my Dutch colleagues here tell me more about Veronica. And that's Ben Martin saying from 1965 to 1970. Well, it seems some people are still on holiday because I'm not seeing a lot of the regular folks here.
Or the opposite, they're back from holiday and busy now with the backlog.
Yeah, Frank de Hart is here from Wellen, Belgium, but yes, some German. Wenn der Chef stört, kann man nicht weiter zuhören. What does that mean, wenn der Chef stört?
He says if your boss is interrupting, you can't continue to listen.
Ah, okay. You know what? We've had a very interesting show. Got a lot of interesting questions. We're about 9 minutes short of the hour, but I think we can wrap it up now because, as I said, either people are on holiday or, as you said, they're back from holiday and they're busy and they don't have...
Before you stop the stream, there's one question that we skipped from Rowan H at 1638. He asked, seeing that biconical antenna from Sebastian, how does the orientation or nearby objects affect a biconical antenna, and how sensitive is it?
Yes, orientation... I saw that one, Rowan. Sorry for missing it.
Yeah, we skipped over it. No worries, Rowan. I got you. So this is essentially nothing else but a dipole. So the sensitivity is the same as a horizontal plane. If you turn it the other way, it's a vertical plane. And everything in between is, what's the law called? E0 times cosine squared of the angle, something like that. I forgot what the law is called. So this is the thing about the orientation. It behaves like a regular dipole because electrically it's nothing different. Nearby objects, the same as with a dipole. So if you do measurements with it, you shouldn't necessarily do it inside your office or anything reflective. If you want to be technical, you have to do it in a anechoic or semi-anechoic chamber. If you have the money for that, most people don't. The other option that there always is called an open area test site. In other words, just a field that's big enough to not have any interference source nearby. You can also use that to measure. And in all honesty, oftentimes we just look at relative measurements. We know that something isn't supposed to be there, and we want it a certain amount of dBs lower. And I can do that inside my office. Of course, there's reflections on the wall and stuff. How sensitive is it? With a biconical antenna with such a huge range, it really depends on the frequency. I think it's no secret, an antenna with such a huge range from 30 megahertz to 3 gigahertz is a compromise. And at the lower frequencies, it's fairly insensitive. I don't want to lie, but I think the antenna factor is around 20 dB there, meaning you have to add 20 dB to get to the actual field strength. So it's very insensitive there. If you get into the gigahertz range, it's highly sensitive. So it really depends would be the answer on that. Now, there is different biconical antennas. If you do want to measure lower frequencies, there's larger biconical antennas for that. Like I said, this is a compromise for quick testing, and the usual ones used are huge. I also wouldn't be able to fit them in the frame, but of course they're more sensitive.
That's a very interesting answer. Rowan H, I hope you got everything you needed from that. I've never seen a biconical antenna. That's why I said it looks a bit like an egg beater, but you learn something new every day. So many different frequencies, yes. And it doesn't have to be a quarter wave dipole for 30 megahertz because that would be huge.
Yes.
Well, well done on trying to get that FM antenna into the frame. I think you're going to need a wide angle lens for your ZV-E10 next time.
Just like that's the funny. I just told my sister in some different regards, I bought all the lenses to get small stuff into the frame, like really small stuff, so that you can even see a single coil with some reasonable distance. And now I got so many new things in, particularly for this electromagnetic compatibility stuff, that are huge in relation. Like I have a complete shielded tent over there, which is just 80 centimeters wide, and I don't know what the height is, but now actually all the lenses I bought, and now I have to find a new wide angle lens just to fit stuff into the frame. So yeah, planning failed on my part, I'd say.
Oh, that's crazy. I mean, today is the first time I've had to move my chair backward to show a product.
And you're using the kit lens, right?
Yeah. Yeah. And I also wanted a good lens for taking small stuff. So even if I had one, I would have had the same problem as you.
Yes, and the cameras, I couldn't reach it. You know, it's back there somewhere. But this was particularly a lens to be able to zoom in, because it always sucks if you have the camera directly over the stuff that you're working on. You're always going to bump into it. So I bought an excellent lens where I can zoom in very far. But if I, like the SDR video I made with the SDR outside, the camera was probably 5 to 7 meters away just to be able to get this box and the bench into the frame. So yeah, but it had to be that way, right? If I would have bought different lenses, then I would have had the problem the other way around. It's always how it goes.
yeah, I'm still looking for a way to get a permanent face down camera above me so you can see what's on my desk, but we'll get to that, I guess. I'm getting new facilities soon, so we'll see what I can do there. It will be rented, so the drilling will be limited, and then I'll have to make a plan, just like I can't put an antenna on the balcony. Anyway, guys, we'll wrap it up now. Thanks, Saad, for being so patient with us and joining us all the way from late night Pakistan.
Thank you, Brian.
And at the moment, Sebastian and I are in the same time zone, but that's because he's observing summertime in Germany, but they change at the end of October. We don't change ever, so then suddenly I'll be an hour later than you, Sebastian. But thanks for joining us today.
Anytime.
Almost 5 p.m. there and here. Thanks to our audience for joining us from around the world again. A couple of thank yous from R. Chris Rourke and Hans Schneider says thank you and goodbye. And of course, another Sebastian Koch says thank you. So thank you all for joining us, and good luck if you're entering the competition. I hope 2 of you win. I can't say I hope everyone will win, but good luck to the 2 who do win. Thank you, everyone. Have a good morning, good evening, good night, wherever you are in the world. Goodbye.